Well, hi, good morning. Thanks so much for coming and keeping me company here in my shop while I work on some old radios. Look at this guy. Oh my gosh. This is one heck of a radio here. It's fantastic looking. And what's really fantastic about it is that this is in like new condition here. This is really, I can't imagine. How did this radio make it all the way here looking like this? Look at it. You'd think it's, I just went to the store and bought it. Oh my gosh, it's absolutely perfect. I don't like that. I don't like that. I like beat up junker radios that I don't bear much risk doing damage to because they're already wrecked. Not this one. Oh my gosh. So, if you've been watching my videos, you know, very recently I was working on a green radio. That's the brother of this radio. They're both owned by the same person. This is the one that she is very, very much in love with, if I can put it that way. So, and I like it too. I think it's fantastic. Word on the street is this radio's working. And I haven't plugged it in. I don't even know what it does or doesn't do. At least I should say this. The clock is working. And by the way, do you have anything radioactive in your house? This might easily be radioactive. If you look at the end of the clock hand, you can see a little white blob there. I'm pretty sure that that's radioactive paint. Now, oddly enough, it's black down here. I think when we look closer, we'll see that, in fact, the paint blob has fallen off and gone somewhere. I don't know where. Maybe not. Or something has happened to make this go black. I don't think it's intended to be black. You can hardly see it. It looks like the hand is ending here. But in fact, oh, is that what they did? No, wait a minute. That can't be the case. This clock looks backwards. You'd almost think this is the minute hand and this is the hour hand, but it's the other way around. Let's just prove that. Yeah. So with this part kind of obliterated, it makes the clock look the other way around. Ah, okay. The other thing about this radio, it's got all its knobs. Look at these. These are, you know, these knobs are usually corroded in through here. They've lost their gleam, their shine. Fantastic. I'm really nervous now. I do not want to do any damage to this clock. There's just nothing on it. Okay. Pretty excited because, you know, aside from that, that's a really cool looking clock. I mean, the clock radio is really nice. I like it. General Electric. General Electric used to be called the Edison General Electric Company. And then, hey, what happened? Did you fall asleep? Yeah, the General Electric Company was originally called the Edison General Electric Company. And then Edison got the boot from his own company. Okay, we should, since the word is, clock works, the owner plugs this in, I'm going to plug it in too. Let's just take a look at the power cord here. Wow, this is from another place. This is really bad. This is really dirty. How can this radio look like this and this cord look like this? It's also, this is a very heavy cord, and look, it's got to be the original cord because, well, it doesn't have to be, but I imagine it is the original cord. Look at this, we got a plug on the back, probably operated by the clock. The clock has it's a clock radio, right? It turns itself on and off based on the time set. This probably goes on and off with it. 1150 watts. And then here we have a really cool input here. So we can plug something else in. Back in the day it would be your record player. But today, of course, it could be a Bluetooth receiver. You could plug a Bluetooth receiver in there, and this becomes a Bluetooth radio. That would be the hope. Well, commonly I don't plug things in and turn them on until I take the chassis out and have a look at it. But I'm going to plug this guy in. We're going to find out what happens. Turn the volume down. Let's see. Pointer moves quite nicely. All feels quite normal. Makes a funny sound. Has the sound of a string tightening as you get towards the end. Had the sound. Got to work it to get all the way to the end. Goes a little over on that side. Stops right there. If you notice on the dial, see a little spot marked right there and another one right here. So this radio must have been for sale in the United States, and those are civil defense marks. And the idea was when you could hear the nuclear bombs coming, you would tune the radio to this spot, and then the announcer would tell you how much time you got left. That's what that's all about. So that's actually the civil defense frequencies for the United States. In Canada, we didn't have such a system. But of course, a lot of American-built radios are up here, and a lot of Canadian-built radios are down there. And I guess this was a requirement. Okay, volume's down. Now we've got some switches here. Here's an on, off. The knobs are kind of in the way there. A little bit of bad design. On, off, and auto. This is set to off. You have a sleep controller. It seems to be in the middle. Maybe not. And set alarm, which will move the red pointer in there. If I pull it out, there it goes. So you can set the alarm. The alarm is set to 6 o'clock. Now this is a 12-hour clock, so that's a little mysterious to me. I think I know these things, but I don't. Something a little funny about this knob too. There we go. You gotta kind of work it to get it to come in. Let's leave it right at 6 o'clock in the morning. You would think you'd want it at. And notice the style of the numbers here: the 9, the 12. Very cool. And these gold dots, little bits of gold on here. It just looks fantastic. How did this happen? This must have lived its life in a box. You know, perhaps it never came out of the box until recently. I don't know how to explain it. Okay, I'm just a little starstruck. Oh yeah, we were working on, wow, this comes way out. We were working on making sure it's turned off. So this is set to off. And the clock is showing, you know, going towards 11 o'clock. Here we go. Okay, now, perhaps this is the first video of mine you've ever watched. So just a couple things before we go a little further. One is essentially I do live videos. Yes, they're recorded and they're posted later on YouTube, usually same day, next day type thing I'm trying to do. But while I'm working in here, this is pretty much a live video. So I don't have a script. I don't know where this is going. I'm just going to work away at things. So you're going to see, you can think of it as real reality TV. You know, a lot of those shows we see on TV, they call themselves reality TV. No, they're not. Not in the least. So, pseudo-reality TV. What's going to happen here is going to be very real. Now I'm going to apply power to this. I'm going to restrict the power using a dim bulb arrangement. The light bulbs are here. And so nothing too bad can happen. That's the idea. Right behind the porpoise. Okay, I can hear the clock running right away, and there it goes. A little noisy, that's for sure. I'm standing a couple feet away. The microphone's almost 3 feet away from the radio, and it's easily heard. So I think originally you wouldn't have heard that sound. Is there something else humming away in here? I don't think so. Okay, we're going to turn this baby on. Now, if something's really wrong with the radio, when it comes on, this light will come on bright. but it may come on a little bit too. So we'll move this to the on position. Volume is down. Here we go. Okay, you see the light come on. And it's dulling down. A little hard to see in the camera, but I can see it. So that's normal. It's behaving normally. Probably pretty low voltage, 50 volts. That's not enough to operate the radio. I'm going to screw in the second light bulb here. Okay, that's going to raise the supply now. It's 107. That's plenty. Turn up a bit. Okay. These particular static sounds, they're not good. This is not good. Well, that sounds like mica problems, or silver mica disease. Very much so. Silver mica disease is a very, very particular type of failure in a radio like this. Not the end of the world necessarily, but it can be tricky to fix something like this. Let's tune around and see if it'll pick anything up. So what we're listening to are the discharges, I guess when I'd say partial discharges, taking place in a capacitor that's molded into a coil system in the intermediate frequency transformers. The characteristic of this sound is it sounds reminiscent of lightning. And in a sense, it is lightning. It's lightning taking place inside this little component that's breaking down. Only a guess at this point, but the sound is very characteristic. Could easily be other stuff. You wouldn't expect it to go away either. Okay, anything? Zero reception. Okay, that's... oh. Well, that's a little odd too. Volume control controls the level of that sound you can hear. That indicates that the problem is ahead of the volume control, so the volume control can control it. Silver mica disease. You can look that up on the internet and read a lot more about it. Some tubes can sound like this too when they're failing. A little surprising, there's nothing coming out of the radio, but there could be lots of other problems too. And that this is kind of odd. Not sure what to make of that. Ground is lost on the volume control. That's an oddball. Okay, let's cut the power. We've heard all we can hear. The next thing we got to do is take this guy out of his cabinet. See, it's held in by only 2 screws remaining here. The other 2 are missing. from it. There's a screw here. This may or may not have to come out. Yeah, I think it does have to come out. Yeah, for sure. Okay. It smells a little bit, but not like something was on fire. Let's look underneath it here. Sometimes there's secret information hidden under here. General Electric Model 913D. Caution! This set is provided with an interlock to prevent dangerous electrical shock. Do not tamper with or attempt to defeat its purpose. To service tubes, remove the 6 screws in the back, then remove the back. 30 watts. 6 screws in the back. 6. 1, 2, 3, 4, 5. Where's 6? Where's 6 come from? Really? That's what it said? Remove 6 screws. Oh my gosh, we got a little bit of trouble here. I see why one of the screws is not in there. Well, this is reminiscent of what I did to Mrs. M's green radio. And I understand now why that happened, by the way, which at some point I'll have her green radio back in here to finish it off. And I don't mean that in a bad way. So you just have to loosen these 2 screws. So what happened here is somebody over tightened the screw or put an incorrect size of screw in and broke the plastic off. This one's good. And the same sort of thing may have happened up behind here. Well, we're going to find out. We are going to find out. The sooner I get this fantastic cabinet out of my shop, the better I'll feel about the whole situation here. When you're putting these guys back together and tightening up screws in plastic and stuff like that, just snug them up. Don't make them tight. Even if you don't break the plastic post behind there, putting a strain on the plastic is going to lead to the plastic developing cracks. So we don't want to do that. If you want this radio to be around 100 years from now, anything hooked up to the back of this? No. Oh, more messages. To replace pilot lamp, I don't remember a light coming on. Turn tuning knob until pointer is at center of dial. Push in and lift up end of lamp holder located at center of rear of chassis. Huh? Then pull lamp holder out of chassis. Caution, this cover is provided with an interlock to prevent dangerous electrical shock. Do not tamper or attempt to defeat its purpose. Oh, I'll be defeating its purpose for sure. But I have other cords. I don't need to use this cord. And you can't remove this, I don't think, from the radio. Put this down. There's more words. Timed outlet, phono input. It doesn't say Bluetooth. Okay. I've set that far away where nothing bad can happen to it. Now, how do you get the radio out of here? So the radio is held in with these bottom screws. Looks like one of which may be missing up here. And what I'm going to do before something sad and untoward happens here. I hear a cat coming. Okay, so just taking a look at this radio here before doing any more to it. So we have some big, ugly capacitors. That guy and this guy, I believe these are capacitors. Big, ugly, molded ones. We've got some resistors in there. It's pretty dirty. This is dirty. How can this be dirty and this not be dirty? So perhaps Mrs. M has done a fantastic job cleaning this thing. Yes, Peanut. You want to go out? No, you can't go outside. He looks forlorn at that moment. I'm going to have to stop briefly and go entertain my cat. Let's see what else we can see in here before I go and make a mess of things. So how's the pointer? The pointer is traveling. Hang on there, Peanut. Pointer. There's a white plastic piece up there. Hopefully it's hooked up to the chassis. What an unusual sort of chassis. It's got a circuit board on it. This would be one of the, certainly not the first, but this is an early use of circuit boards. Yeah, all the tubes are there. This is a 5-tube radio, 1, 2, 3, 4, 5. It's got a tube rectifier, and it has no power transformer. So this is a bit of a dangerous radio. You pull these knobs off. Oh my gosh, it's sticking right out. Pull this one off. This is silver, this is copper colored. Did they replace one of these? I don't think so. But pull these knobs off. This one's going to be tough. These are tough to get off sometimes. Oh boy. Hang on there, Peanut. Yikes. These are on pretty tight. Okay, so maybe we're going to try to take the radio out but leave the clock behind. Now how can we do that? So the clock power it's coming right from here. Yeah, I'm going to have to go entertain my cat here because he's going to... I don't like to disrespect my cat. Oh, there's more information to read. Let's read it. Here we are. General Electric, the tubes involved. Oh, 12 AU6, a little unusual. BA6, 50C5, AV6, and 35W4, all common tubes. The 12 AU6 is a little unusual in a radio like this. Super heterodyne, 455 kilocycle IF, 30 watts, 30 watt consumption. Refer to instruction book for best performance. Warranty. Refer to instruction book. For best performance, always use genuine electronic radio tubes and component parts. Where is it manufactured? Manufactured on 1900 Bleecker Street, Utica, New York. It's an American, made in USA. It's an American radio. That's why it's got the civil defense stuff on it. Okay, Peanut, I'm coming. Let's go rest. You gotta rest. It's not that my feelings were hurt, but my cat just wanted some food in his bowl. He didn't care about me at all. So a couple other interesting observations here. There's a shielded, looks like a spring, there's a shielded wire coming up to the phono. And this thing here, what is going on here? Is this the light they were talking about? It's on a funny angle. Don't know. And there's a copper post sticking out here. One of the screw is missing. This one's in. I photographed the wiring up to the clock. The objective here is to get the chassis out, leave the clock behind. I'm going to leave the speaker in too. You can see someone else has previously unsoldered and resoldered the speaker wires. I'm going to do the same. I don't think I want to try unclipping it. There's no reason for me to bring the speaker out. So what's going on with these wires? Now these two wires here are joined to a terminal here. They travel one goes onto the board here, and the other one comes to the plug. Looks fairly easy to unsolder this. And what is that? That's up in this part of the clock here. No hint there. Well, we got to guess it's a switch. So it looks like I have to detach this wire and this wire, and this joined wire up here, which looks. So sometimes when they put a wire, usually wires are twisted around the post and then soldered. So unsoldering them, you still have to untwist them, and that's tricky. This doesn't look like it. It looks like they just shoved it through and soldered it. If I melt that, it looks like the wires will come right out. And I'm taking my time with this because I don't want to make any mistakes, do anything unnecessary. You can see the AM radio antenna here. It would appear there's only one wire coming from it. The other wire is tied to the bracket, which is then grounded into the radio. So that's where the other antenna wire is. So that's going to come out too, no problem. All attached to the chassis. Okay, I think that's the plan. To remove, should I take it from here? This is easier. So on the back of this terminal here, way down here, is three wires soldered there. So I think I'm better off taking it off of here. Looks easier. Take this one off of here. Notice the coloring. This one is a light colored wire and all the rest are dark. What's that mean? So let's get the soldering iron out here. Start with this one up here. I'm going to hold these wires. They're going to get hot unless I'm quick. I don't want solder dripping down into the motor mechanism there either. There's a possibility of that happening. So I think what I'm going to do, I'm going to grab them with this. Go like that. This right up. You may not be able to see this necessarily. I think you can. See what happens when I get the soldering iron going here. Soldering, you know what? That's not going to solder anything. You know why? It's not hot. Hey, didn't turn it on. That would have taken a long time. Okay, we're going to try again. I'm going to use different pliers. Okay, she's up to temperature now. My hand's in the way during the making of this part of the video. I can't do anything about that. There we go. There's a lot here to heat up. Misunderstand something here, it's not going to loose at all. flipped pretty easy. So the soldering iron, you know, when you're using it without solder, the contact between the soldering iron and the work is small point. You're trying to deliver heat through that contact. You just may not be able to deliver enough heat and raise the temperature successfully. So I'm going to throw a little solder in there, and that should help transfer heat a lot better. There we go. Okay, just as I thought. That's one done. Next one was this one here. Now this is probably wrapped around the terminal. Let's see. Once again, if my hand's in the way, sorry. Gonna splash solder. Let's need the safety glasses on. There we go. Whew. Okay, and then the last one is this one here. This might be a little easier if I release the chassis and pull it out a bit. There we go. Okay. It should be able to pull the radio out and leave the clock behind. Okay, take off that screw. Oh, there's another one here. This is loose. Now I can see inside the radio is there's a fair bit of, not a fair bit, but there's some dirt on the inside. So if Mrs. M is the one who cleaned this radio up, boy, she did a great job. You'd think you could only get something cleaned up to this point if you have the radio right out of it, everything right out of it, clock and all. I just have the feeling she didn't do that. So, oh, I forgot about the speaker. These are probably, oh, it just came right off. Didn't even have to put solder. I was going to say these are probably tacked on by a previous person and not on here very, very good. Well, that's true of the green wire there. There we go. Just tacked on. Tacked on as opposed to being wrapped around or even put through the terminal there. Everything's coming out. Yep, we did it. Okay. So this pink cabinet, it's going to the protected zone. There we are. I can breathe easier now. Now we can get a look at the... Oh, okay. I see something already. Very unusual. So on the back, I had noticed this kind of strange arrangement here, and there was a weird instructions about how to change the light. Well, it's all clear now. Look at here. The light is inside of this. And as you tune the radio, hey, come on. Oh, that's the volume. As you tune the radio, the light bulb is going with it. And so I can see the light bulbs right back in there. And it looks like there's a slot for the light to come out. My guess is the light comes out and just fills this area around the pointer. Down here. Fills this area around the pointer with light. That'd be really cool as you dial back and forth. Now I didn't see any light, so I bet you the light is burned out and nobody even knew it was in there. And then changing the light, they've had to come up with some scheme so you can withdraw the light from the front of the radio out the back, change the bulb, and then put the whole thing back together. Never take the radio out. That would be my guess. So these are all original parts here. This big capacitor, the one over here, this may be a capacitor too. Probably bad guys. This is the filter capacitor. I don't recall any hum in this radio. And this guy also has a very early integrated circuit right here. Let me turn up the light here, just maybe it'll help a bit. Yeah, so you can see this guy here. If this is a problem, this is a problem. It's got 1, 2, 3, looks like 5 leads coming out of it. 1, 2, 3, 4, looks like 5 leads. What's inside this little thing here are some resistors and some capacitors. There could be 3, 4, 5, 6, 7 parts in there. It forms a network which is required in these radios. A network is just a combination of carefully put together combination of components like resistors and capacitors. And so radio manufacturers took advantage of these kinds of parts. Rather than putting in discrete parts, they just pop this in and there you go. Make five soldered connections instead of 15. So one of the wires going to the speaker is grounded right onto the chassis. These are just things worth noting while we're doing this. Now I didn't really get into it. This is a hot chassis radio. All these small 5-tube radios with no power transformer are of that sort. Let's look underneath. I gotta bend the antenna. Well, this is really quite rigid. That's really quite strong. There's nothing under there. Wires going. So here's why this knob is different. Look, it's a big long shaft. That's what's sticking out of the back here. Got some kind of spring deal with it. It looks like what you do is I think you push this in, it clears the clip, and then you can kind of bypass the clip and the whole thing comes out. I'm not going to do it, not right now. Looking for any evidence of damages or strangeness, anything weird going on. These kinds of radios, circuit boards can have cracked solder connections. But the problem we were listening to, the static problem, is almost certainly, I shouldn't even say that, coming out of these tubes. I'm sorry, not the tubes. But what am I thinking? I'm thinking ahead while I'm talking. Coming out of these. Inside these cans are a couple coils and some capacitors that are potentially inherently connected. Inherently built. It's not even the right word. Integrated. That's the word. Integrated capacitors inside here. There's a lot of dirt down in here. There's dirt all over the board. So that radio must have been a filthy mess at one time, and it just looks beautiful. So whoever it is that should be praised for cleaning that guy up gets my praise. Cleaning up the radio. I'm just looking to spot anything else I should be spotting at this point. There's a bit of an unusual component way down in here. A little tiny guy. Not sure what that is. Not many parts, eh? See, there's a good number of them are inside here. Now, the static sound could have been coming from it too. That's a little tricky to detect, except by putting a bad tube into something like this and listening to it. It really had the characteristic sound of failures inside here. But it could be a tube. And plus the radio didn't work. didn't produce any sound. The crackling sound we were listening to, if it is coming from a failure inside here, unless it's terrible, I don't think it would cause the radio to not work at all. But it seemed to not work at all. So I'm going to guess there's another problem that's causing the not work at all deal. And a tube is the most likely thing. These tubes are in series. The heaters are all in series. So if one tube heater isn't working, the whole radio is dead and make no sound, but this radio made sound. So we know that all the tubes are heating. I'm going to have to run them through the tube tester. I think that's going to be step one. Are these even the correct tubes? Almost certainly they are, but certainly they are doesn't pay off. Let's just take a look and see. Sometimes these can be in the wrong sockets, all kinds of stuff. This is the 12AU6. That sounds like that's in the right spot. So the signal's coming in from the antenna on the front part. It's getting into this tube first. It's traveling through this can into this tube. This should be a 12BA6, and it is. Yeah, if these tubes are in the wrong spot, I think we probably would have known it much earlier. And they can't be wrong now, I don't think. Let's see. So this is the AV. 12AV6 has a particular look inside of it. Okay, this tube's job is to recover the audio information from the radio signal. It does other things too. Now this is probably this is the speaker driver. It's a 50L6, 50C5, 50C5. Okay, these are all the right tubes, I'm sure. And this last one is a rectifier 35W4. 35W4. We're going to start by testing the rectifier first. Okay, I'm going to get the tube tester set up and we'll get through that. Let me just turn the lights down here because it's very bright, like it's like sunshine in here. There we go. Okay, coffee break, then tube testing. Okay, let's give this a try. 35W4. Just be absolutely sure that's what I'm doing. 35W4. Double checking things. 35 volts on the heater. The numbers are 00763, 00763, 0100, 0100, 25 on the sensitivity, and the plate is on E. We are ready to go. Now, if this tube wasn't working at all, the radio wouldn't have worked. We wouldn't have heard anything out of the speaker. So, chances of this test coming up bad is very low. W4. So when we're testing a rectifier, there's a special area right here under my finger. It says rectifier is okay, as long as we get above where my finger is. Okay, we'll look first. We'll do the short test here. Oh, this has come up a bit. Yeah, I don't know about this tube. Oop, showing a short here also. There is a way to interpret these numbers, 1, 2, 3, 4, 5, and determine what kind of short it is. It's a high resistance short. It's showing 5 megohms here in the measurement. So if you had a bad short in a tube like this, you would not want to continue with the tube test. This is a kind of a minor short. I have the feeling we're going to have to replace that. So let's pull the switch here, rectifiers and diodes. So it's way up in the good. Let's just check this again. Yeah. So probably setting 3 and setting 0, or 1 I guess, setting 1 and 3, you're doing exactly the same test, maybe in a different direction, sort of getting the same reading here. Now the falling off and coming back is probably because the tube pins are losing contact in my tube tester. A little more carefully. Yeah. Okay, it's going to be too hot to touch already? No. Well, 35W4, I'm pretty sure I've got lots of potential replacements for that. So there's one down. Okay. Now the next tube I'm going to do is the next most likely tube to have trouble, and that's the output tube that drives the speaker. Okay, we're ready here. Let me just double check. So it's a 50 C5. We set this voltage to 47. Well, why not 50? I don't know. 47. Signal level is 4. Bias is 12. High. The numbers are 1576G, 1576G, 4300, 4300, 50C5, 32 on the meter sensitivity, C for the plate. Just before I turned the camera on here, I had set this whole thing up and then realized that I was actually on the wrong line on the chart here. Which happens, it happens so easily. That's why you see it. I got my finger over here all the time pointing at it. I'm trying to make sure my eye is following the right line here because it's so easy to make a mistake. The weakest you want this tube to be is 1220. In other words, that's the reject point is around here. Okay, so output tube drives the speaker. It's a hard working tube, and somewhat intentionally it can't tolerate its own use all that long compared to other tubes. So this tube wears out a little early. I guess if they made 50 C5 tubes to last, forever, the tube would be bigger and much more expensive. And besides, part of the business here with these old radios was tube replacement. I mean, the tubes were a big part of the business. It's like the ink in today's printers, which I'm feeling very bad about because I have to go spend a pile of money again. I had this up on 3 when I did the test on the last tube. That was a mistake, but I don't think it matters because I'm going to be looking at replacing it anyway. It's just sitting here. Shame on me for doing that. Okay, tube is definitely warmed up. I mean, it's glowing like crazy. Here we go. Any shorts in here? Okay, so the meter would come up if there was. There aren't any. So GM test for the transconductance of the tube. And remember, it's got to come up above 12. Wow, she's way over there. Okay, so the output tube is good. This is going to get hot. Look how much that is. It needs a big cathode because it needs to drive a lot of current. Big hot cathode. Okay, Mr. 50C5 goes back in. He's okay. Very good. It's probably been replaced from the original tube. And next, now I'm going to go to the front end of the radio next. Okay, I'm ready for the 12AU6. Here, let's just double check. 12AU6. 13. Yep. 4. 10L 52763 52763 4100 4100 42 C. We're good. Let's see if the tube is good. It doesn't seem to be heating. That's a little odd. So whenever I have trouble with a tube in a tube tester, I always doubt what I'm doing. I think, okay, it's probably me. Now, this just may not be making contact here. Watch the pilot light for a flicker. There. As you can imagine, plugging in dozens and dozens of tubes eventually wears out the sockets on a tube tester like this. So, there we go. Now, there we go. Any shorts? No. If you can see the meter coming up a little wee bit here, that's normal for these tests. It comes up just a little wee bit. That's just normal. Okay, in this case, this tube should be thrown away if you can't get above 1250. 1250 is above the same spot there. There we go. She's a winner. Very good. 12AU6 is good. Okay, just in case you're not familiar at all with tube testing, you're wondering what do all these knobs do? They decide what's hooked up to what pin on the tube. That's setting the, because all the tubes are different. And here we go. 12BA6. Okay, 13 for the volts, 4 for the signal, 10L for the bias, 52763, 52763, and 4120, 4120, 33, C. Okay, let's try this one here. Okay, it's heating up. One of the things I'm keeping in mind when I'm using these tube testers is, yes, they could be worn out, and one of the pins may not be making contact in here, and it can cause the test to go south. So, as I mentioned before, anytime I get a bad tube test, I doubt the test. I doubt me and the test. Anybody shorted in here? No, nobody is shorted. In this case, this guy should come up to 960. So it's just got to get up around the 1000 mark here, and we'll be happy. Oh, it's a good one. Yeah, this radio's full of good tubes. Okay, next tube. Okay, I'm already on this tube. Now, this tube is actually 2 tubes in one. It's got an amplifier in it, and it's got a couple diodes in it. And so they get tested separately in this tester. So the first thing we're doing is we're doing the amplifier part. Okay, 13, 1, 19L, 51760, 51760, 0300, 0300, 35, F. Okay, we're good. Pop it in. So the job of this tube, as I mentioned, it's 2 tubes in one. It has a couple of diodes in it. Those diodes are used to reveal the audio signal that's in the radio signal that's come into the radio. So in a sense, you could think of it this way. This tube is splitting the RF away from the audio, the AF. You could think of it that way. And the other job of the tube, quite separate, is to amplify that audio signal and sort of preamp it for the big output tube. The output tube needs a strong signal on its grid. This guy's got to supply it. So that's why there's 2 tests listed here. The first one is the amplifier part, and we should be looking at a transconductance, mutual conductance, whatever you want to call it, just over 1000. So just over here, there we go. It's not so good. Okay, I'm holding it for a bit. The tube is still warming up. This is still climbing up. This doesn't mean the tube is bad. This means the radio repair shop has an opportunity to sell the tube. That's what this means. So it's pretty darn close to 1000. Now we're doing a little sensitivity check. What if this control were moved a little bit? See, look, it doesn't take much to get it up there. Okay, it's supposed to be at 35. And what if the bias is a little off in my tube tester? See? So if these two are a little off, you could get a reading that would be at the reject point. But a good tube here would actually be up here somewhere. So it's on the fringe, but still functioning. Now let's take a look at the diodes. I gotta pull it out, I think. I don't like changing stuff on this tube tester. So it's a diode. We don't care about the bias, or the signal. We don't care about the bias. We care about this though. 01763. P01763. I'm counting on you to double check what I'm doing here. P000. P000. Yeah, you're double checking? 48. You let me know if I'm getting this wrong, because I'm not going to double check it. A. I'm not going to double check it because you're watching me. Okay, here we go. So now the other part of the same tube. It's actually two tests we're going to do. We're going to flip this switch, do a test, flip the switch, and do another test. If we don't push the GM test button now, we're going to push the rectifier and diodes button. The rectifier's got to come up to here. Diodes only have to come up to here. There's a little spot there. It says diodes okay above this line. So we'll check for shorts. Taint any? Taint no shorts. Rectifiers and diodes. Uh-oh. No response. Okay. See? Now, did I do something wrong? You were supposed to make sure I didn't do something wrong here. So 13 D 01763. 01763. P000. P000. 48 A. Let's try again. Oh, you know what's going on here? That's the tube socket problem. Yeah. Okay, so we're up in the good range of the diodes, but there's another diode. We get to it this way, and it's showing much weaker, but still in the okay. So, you know, if you had lots of money, 15 bucks, change that tube, get something a little better, or continue with this. It's working. It's just not maybe the best. 13. So no real big problems with the tubes, except the rectifier tube. It's just a little scary with a partial short in it, and you could imagine what's going to happen here is the short is going to get worse in that rectifier tube. Put this back in. Okay, I'm going to get myself a good 35 W4. That's what it was, wasn't it? It was a 35 W4, yeah. GE. And I think we should change it. Okay, my records say I have a few in bag number 19. These are my combo bags from bag 10 to bag 19. 18, 17, 16, where's 19? 18, 15, wait a minute. 19, here we are. So in this bag are basically essentially random tubes, but I have an index that I keep track of all this stuff, so I know that what's in these bags. There's various tubes in here, but among them are going to be a bunch of 35W4. They are tall tubes and very simple inside. So, you know, some of these probably aren't. Yeah, those are all the tall ones. Maybe these are all 35W4. W4. Taiwan. This one's made in Taiwan. A Sylvania tube. I'll assume it's a W4. I can't see the thing. 35W4. And 35W4A. Sometimes, you know, the extension, the A extension, means it's a later tube, and sometimes it refers to how fast it heats up. Not necessarily in this case, but until this rectifier tube heats up, there's no high voltage in the radio to operate the other tubes. And sometimes there's a timing issue on warming the radio up. You want certain things to get to their spot first and second, third. I don't know what the A really means about this, but it can probably be popped in place of this one, 35W4 with no A. And these tubes have all kinds of marks on them, including funny patterns of dots. Look at that, can you see that? Funny pattern of dots. Yeah, I can see the pattern there. Numbers all over the place, aside from the key number. And this is keeping track of what factory it came from, and other, this might have been, you know, what month, what, you know, that kind of stuff. It's all coded on a lot of these tubes. Okay, that's the bad one though. Don't mix them up, Jim. Put the bad one on the tube tester. Good. Oh, I gotta test these now. Don't put it on the tube tester. That's where you're gonna mix it up. Stick it back in the radio. Okay, bad guy back in the radio. Okay, I'm gonna just test these until I find one that's good. Probably the first one will be fine. They're all good. All these tubes are good. Some of them may not be really good though, but they're all working. Okay, we're ready to go with a potential replacement in there. We'll do the shorts. What's going to happen? That showed a short on the other tube, but nothing here. All looks good. Rectifiers and diodes. Rectifier's got to come up to here. She's a winner. Okay, so there's a replacement. No partial short or anything in it. We'll put this guy in the radio. These tubes are a little expensive compared to others. The reason being, they wear out, and so they've become rare. But there's a lot of them. Rare, but there's a lot of them. It's not gonna come with that. They're very common tubes in the sense that many little radios use this tube. Now I gotta put these back. Don't forget. Now, is this going to solve the problem? That's interesting. That's interesting. A partial short in the rectifier tube could cause that sparky sound we were hearing. I wonder. I certainly wonder. Well, we're going to find out. I've got to wire this up so it'll operate, so we can plug it back in. And I got to do the speaker. I got to do some stuff. I got to have a coffee. Yeah, let's go. Coffee time. Okay, I think we're about ready to go here with an actual test. So let me rotate it around here. Power is going to be coming in here, clip leaded to these two wires, which will feed power into the radio. So the radio is going to be on because the on-off switch is disappeared with the clock. So it's basically on as soon as I apply the power. If I've got this wrong, which I don't think I do, but if I did have this wrong, then those dim bulbs are going to save the day. I won't have to explain to my wife why the lights went out in her house. Okay. Sure the volume is turned down. You see how they've got a pulley here? Take a look down here. A pulley here on the volume control, which, see my finger, I'm holding it still. The volume control shaft is the support for a string pulley for the dial. Isn't that unusual? Every time I look down I think this is the tuning knob because the string is going over. I've seen some of these where there isn't even a piece here. It's just the string just goes right over the shaft. Yeah. Okay, just taking one last look. And what I'm doing now is I'm seeing particular if these wires are going to go somewhere. Really unfortunate. So, no, I don't think so. Okay, right. So I'm going to keep the dim bulbs in view, and I'm going to revert back to just one light up here. One small light. So all the power is going to go through this bulb. That's going to really restrict it. That's how worried I am. Plug it in here. This is into an isolation transformer. Provide me some additional safety, especially with a 5-tube radio. The chassis here can be live at 120 volts to ground, You're grounded. Maybe you're standing with your bare feet on your cement floor and you touch that thing. Woo! Don't do that. Read up on hot chassis problem. 5-tube radio. I hate to say this. All American 5, AA5. Well, this is an American radio. It's American built radio, so this is an AA5. But lots of Canadian radios were designed and built here in Canada, very similar to this. I guess those would be an all Canadian 5, but nobody says that. Okay, no use delaying any longer. Here we go. So I'm going to throw the switch over here. Going to keep our eye on that light bulb. It's going to go bright because we saw that before, and then dull down a little bit. The question is, are we going to hear crackling, or is the crackling gone because I got rid of a crackling tube? Here we go. Put a little volume on it. Waiting patiently. Okay, tubes are warming up. Very low voltage, 66 volts. It's way low. So I am going to screw in the other light bulb. That'll bring the voltage up close to line voltage, 109 volts. That should be enough. Now I've got an external speaker hooked up here with these lines to a speaker up on my wall here. Well, that's not good. It's definitely not good. Let's see if we can find out if it is one of these by mechanically playing around with it and seeing if it affects the sound that we're hearing. So we'll try this one first. This is not likely to do anything, but who knows? If I can get that sound to follow the pattern of my mechanical deals here. You know, it's changed a lot, but is that because of what I just did? Now remember, in this radio is plugged into a regular outlet. There's a 50-50 chance the chassis is 120 volts on it. Be the same as this, so I'd be grabbing 120 volts here relative to ground. But I'm using an isolation transformer, 2 of them in fact. So I can't get that kind of shock. Well, I can get other kinds of shock. See, my hand is pretty close to the 105 volts here. So it's gone away. But oh, there's a bit of a radio sound back there. Give it a tune. That was kind of weird. There's a lot of coincidence going on here, so the noises we're hearing are really quite random. You think about lightning. Lightning is completely random, right? You never know where it's going to go, when it's going to come. Same with this stuff. But we're not picking anything up whatsoever. Let's try this. Nothing. So that should have caused some effects out of the speaker, like a when I'm touching stuff. Nothing's happening. No signals making it through this radio. Now, in other kinds of radios, you could pull out a tube to isolate parts of the circuit and try to, home in on which part is making the sound. But in this radio, you pull a tube out, they all go dead. So you can't do that. There's other ways I can do it. Okay, let's try wiggling this one. No, that was it. Just scared myself. If you do this work, you're on edge too, I'm sure. So this doesn't seem to have any impact on the sound. Does it? So I'm looking for the sound to move in coordination with the pattern of my movement here. The sound to change. Nothing. I'm going to try something a little more dramatic here. Dramatic? Maybe not dramatic. So I'm moving the cam, but that doesn't mean I'm moving the parts inside. So I'm going to try to move the parts inside a little bit. Well, so we know the problem is coming before the volume control. So it can pull a tube out, and for a very short, I can pull this tube out or this tube out, and for a short period the radio will continue to operate because there'll be heat in the remaining tubes. So we can do that to try to isolate the problem a little bit. We already know it's before the volume control. So the tube to pull out is this one. So pull that tube out of there, and then just for a couple seconds, let me turn this up, we'll be able to hear the radio operating. We'll see if the clicking goes away. No, I don't want to touch this. I don't want to do this. I wish I had a tube puller. I don't have a tube puller. I have to use my fingers here. A good question would be, is this thing ready to explode? Is this the lead up to an explosion? Don't think so. Can I pull that out of there? Okay, as soon as it comes out, we listen. What's all that sound? It goes on for a long time. Oh my gosh, it's still going. It should go quiet. There it goes, finally. That's how long it took the heaters to actually cool off in these tubes. Okay. What did that tell us? Well, you can't hear anything before this tube. So you can't hear this, or any of this stuff up here. Can't hear any of it. But yet the crashing sound was going like crazy. In fact, am I crazy? It seemed to get a lot worse. Let me turn the power off here before I get a surprise. That implicates this, or the problem is something else, and I'm misinterpreting it. Yeah, that is definitely the classic sound of silver mica disease, SMD. It's so common it actually has a short form. So I invite you to type in silver mica disease into the internet and read on if you don't know about this. For a lot of these small radios, that's the end of the road, because nobody wants to try to fix that, because it's a journey to get it done, and is it going to work after you do it? And what is the repair process? So we have to remove this part from the radio and take off this cover. Inside is basically 2 coils, and then at the bottom, in the plastic base of what's inside here, are 2 capacitors incorporated right into the base. So the idea was, if you're a radio manufacturer and you pick this kind of IF transformer, intermediate frequency transformer, it comes with 2 capacitors already in it. Why? It saves you from installing 2 more capacitors in the radio. So similar in a way to this thing, it saves manufacturing cost. Cheaper to do this than to put in discrete parts. Now the solution is, get this guy out, find those 2 bad capacitors that are in there, cut them away. That's the tricky part. Cut them away so they're gone. They'll physically still be there, but they won't be connected to anything electronically. And then put discrete parts to take a bit of a guess about the size of them. Couple capacitors, small capacitors. You would install them. You could install them in the can, or you can install them, if you're lucky, down here. Wow, that looks a little tough to install stuff down in here because of this thing's swinging back and forth. It's probably a good hour to do one of these, with a question mark about success. Another difficulty here is there can be more problems in the radio. As serious as this? No, I don't think so. But you could do all the work on this, pop it back in the radio, turn the radio on, doesn't work. Maybe it's not working because of that. Maybe that. maybe that, maybe. So you start changing all these out to get rid of these old. I'm pointing at capacitors here. Not too many. 1, 2, 3. This one doesn't even count. This one is hooked up to the input if you want to run your phone in here. So this is not even affecting the radio directly. Just these two, really. And this guy. This guy's a real problem, because he's got resistors and capacitors inside. Easily one of those can be shot. I could shut down the radio's operation. It must be repaired. Sometimes you can stick a discrete replacement component, leave that in there, and just as luck would be, you can manage to install a discrete component maybe underneath. But other times this whole thing has to go, and you have to create a new network of all the parts that are in here. That's bad. That's very bad. The problem is you might not find all that out until you get this thing solved. And you could even solve this and then find out it wasn't this all along, it was something else. I don't think that's very likely. One possibility is this one is also doing the same thing, and just because I pulled the tube out, and so this one was no longer operating or couldn't affect the sound, as far as I know, you couldn't hear it. It could be both of these guys are making that crashy sound, and when I pulled the tube out, okay, we just hear this one. We think it's only this one, but it's this one too. So add that in. That's a couple hours. It's somewhat risky work, a little bit risky in that you could work away at this and not get it done. So we got a bit of a problem here because that's such a nice looking radio. Now I'm telling you, I got the solution. I think the solution is to abandon the radio in here, concentrate on making the amplifier work. It's simple. It's just a couple of tubes. These three tubes basically are needed to make the amplifier work. And then turn this into a Bluetooth radio, because it's got the phono input back here. So we can make this work. There's a good chance of that. These parts that are in trouble, they're part of the radio. And you know what you're going to get out of this radio anyway? It's just an AM radio. So, what, do you really want to listen to AM radio? So I think that would probably be the best way forward with this guy. Concentrate on turning it into a Bluetooth radio. Bluetooth receiver, what's that, $50, $40, not a lot of money. And then you have actually a really good sound source. You turn this into a jukebox from your telephone, basically. And of course you can always, there's a application here in Canada called Radio Player Canada. I have it on my phone, and that gives you quick access through the application to almost all the radio stations in Canada, certainly all the popular ones. So your radio station can easily be coming through your phone. This thing will sound just like a radio again. I think that's probably the best way forward. Otherwise, a lot of money at risk, or effort anyway, trying to make this thing work. And the end result, what do you get? You get a crappy AM radio out of it anyway. And why is it crappy? It's not so much that these radios are crappy. They are crappy. These are crappy radios. But beyond that, the environment they're in is really crappy because of all the crazy interfering noises from computers and all that kind of stuff. So listening to AM radio, it's only going to work if you pick up a strong, strong station. So I'm going to drop it here. I'm going to stop here. Mrs. M's going to watch this video. She's going to hear my story here. She's going to hear me encouraging her to abandon the radio part. We can still put a light in here. You can still turn the dial and see it go and all that kind of stuff. But otherwise, this thing is going to become, I think, its best way forward is a Bluetooth amp. Basically, Bluetooth amplifier is what it would turn into. Beautiful looking radio, would be ashamed to not be able to use it at all. That's kind of where it's at right now. In terms of silencing this radio so we don't hear that crashy sound, so we got the Bluetooth plugged in, there's probably a wire or two I can snip that'll cut off any of this crashy noise from reaching the audio amplifier coming out the speaker. And we can probably, this tube, these tubes can't come out, unfortunately. They got to be in there because you need all the tubes in place. So unfortunately you still need these tubes just to have the heater current flowing through them. I was going to say you could probably pull these tubes out, cool off the radio a little bit, drop the load a tiny amount. The amount of power in these heaters, like 4 or 5 watts, 3-4 watts, not a lot. I think this thing said it was a 30-watt radio. So you can imagine just from the heat that comes off these two tubes, 10, 20, 30. That's my calculation. So thanks a lot for watching from here, but I think the story has been written for this radio. Okay, I'll see you on the next. I don't know what's coming next on my bench, but we'll see. I'll find something. See ya.